So this is a highlight for the problem 2, force acceleration 3, and the solution on the PDF that here I just want to explain some key concepts just in case you cannot follow with the PDF solution. So this here lawn roller has a mass of 80 kilogram. The radius of gyration kg 0.175 meter. If it pushed forward by a force 200 Newton, when the handle is 45 degrees as shown there. Determine the angular accelerations of the roller for sure, and acceleration at the center G, and they have the coefficient of static and kinetic friction between the ground and the roller is mu sub f 0.12 and mu sub k 0.1, and check assumption you met. Classify motion, GPM, properties 80 kilogram mass, so you change to the weight, time, just basically time 9.81, right? So that basically 80 times 9.81. And then IG equal to mk square, so that and 80 k 0.175, so you have 2.5 kilogram meter square. And that draw diagram, free body diagram, equal to kinetic diagrams, and in this case it's only one body, so we draw two, one free body diagram and one kinetic, make them equal. So have the force 45 degree and the weight 84.4, friction force assume go to the left, and then normal force. In kinetic diagram, if you apply the force that way, the wheel will tend to move to the left and it rotates counterclockwise. So that's why you have IG alpha counterclockwise and MAGX go to the left. No MAGY because the G, similar to the problem 2, it parallel to the ground, so it not jump up and down in y direction. No MAGX. So you can go with the x or y direction first. So the x, so basically what that number come from, it basically a cosine 45 degree. Cosine 45 degree and 200. So you have x and negative because we assume counterclockwise is, go to the right positive. So it's cosine 45, 200 negative, minus also f, and then the other side also minus 80 MAG. No, it's 80 already kilogram, so we have to remove that one out. Nothing here. Okay, so 80 MAGX. So from that, assume no slip. We talk about that later. Let's do the y direction. So the y direction, so to find out, this is the weight, this is 200, so this is sine 45 degree, 0.707, 200 plus normal force, so we have normal force equal to that one. So that problem equation in y direction gone because we already find out n. Mt, so it will be equal to IG alpha about G. So in here you see the weight go through G gone, normal force gone, the force F P, force P also go 200 Newton go through G, so no moment, only the friction force. So you have and the radius of that one is 200 millimeter, so you can have that one here is 0.2 meter. So from that you can have 0.2 f, and you assume counterclockwise positive, clockwise is positive, and f is clockwise, and the IG alpha in your kinetic diagram is counterclockwise. That's why you assume clockwise positive, so that why negative in there, negative in IG alpha. And IG we already find out 2.45, so it's negative 2.45 alpha. And from that, how many equation we have? Ignore the equation in y. You have 1 friction, 2, and you have in that case you have equation the 3 here. So from that 2 equation, 3 knowns, F frictions, the second is ATX and alpha. So you assume no slip wheel, that is the green one in here, and when it no slip, I have ATX equal to alpha R, so 0.2 alpha. So we can plug it in equation there, plug in that equation. So you will have 2 equations, 2 unknowns. So this have set up that equation for F and alpha after you plug AGX equal to 0.2 alpha. So you have that equation 1 and 2. And from that you can find out F equal to negative. Negative mean it opposite to your assumed direction. We assume go to the left, so it actually go to the right. Okay, and they say we assume it no slip wheel. We assume you have to check your assumption. So in that case, mu F max equal to mu sub Sn. From the y, we already know n equal to 926. Mu sub s is 0.12, so you 0.12, 111 greater than 61. So it no slip wheel is good. Where it no slip, so you don't have to continue. Box your answer, so it will be alpha. This will be the answer, and ATX equal to alpha R because no slip. That's why we have that equation. So it will be the answer we have, and the answer we have. And negative, that good as well. So it equal to 61.0 Newton. Go to the right if the question asks us the friction force. So with that, I hope you can capture the key concept for this problem, and we go good from there. Good luck.